The U1000 diagnostic trouble code in Nissan vehicles indicates a critical malfunction in the controller area network, or CAN communication system. This network is the backbone of modern vehicle electronics, enabling communication between various control modules. The CAN system connects multiple electronic control units, including the engine control module, body control module, ABS system, instrument cluster, and other critical components. All these modules communicate through a shared network using standardized protocols. The CAN system consists of three critical components. First, the CAN high and low lines are twisted pair wires that carry differential signals at a nominal 2.5 volts. Second, 120 ohm termination resistors are placed at each end of the network to prevent signal reflections. Third, various electronic control units serve as network nodes, including the powertrain control module, body control module, and ABS system. Industry data shows four primary causes of U1000 codes. Physical wiring issues account for 40% of cases, including broken or damaged CAN wires and corroded connections. Faulty ECU modules represent 25%, typically involving internal CAN transceiver failures. Termination resistance problems cause 20% of issues, often from open or incorrect resistor values. Finally, electromagnetic interference accounts for 15%, usually from aftermarket installations or damaged shielding. Advanced OBD2 scanners now offer sophisticated diagnostic capabilities for CAN system troubleshooting. These tools provide real-time CAN bus monitoring with oscilloscope functions, allowing technicians to visualize signal integrity and identify intermittent faults. Modern diagnostic protocols include multi-module communication testing and enhanced fault isolation, significantly improving repair success rates. The diagnostic process begins with an initial assessment using a professional scanner to verify the U1000 code and identify any additional codes across all vehicle modules. Next, perform basic electrical tests by measuring CAN high and low voltages at multiple points and testing termination resistance, which should read approximately 60 ohms across the CAN bus. Advanced diagnostics involve using an oscilloscope to analyze CAN signal quality and identify communication issues between specific modules. The oscilloscope reveals the actual signal integrity and timing. The repair process follows a systematic approach. Address identified issues, perform necessary software updates, and conduct comprehensive system testing to ensure proper communication is restored. Industry statistics from 2023 to 2024 show that U1000 codes represent 12% of all Nissan diagnostic trouble codes. Repair success rates vary by approach. Wiring repairs achieve 85% first-time fix rate, ECU replacement has 92% success, and software updates resolve issues 78% of the time. Successful U1000 code diagnosis requires a systematic approach, combining proper diagnostic equipment, methodical testing procedures, and adherence to manufacturer specifications. This comprehensive process ensures reliable communication restoration in the vehicle's CAN network.